This is the third video in my series on randomized control trials, and this one's talking about the factorial design. So typically, like in our regular format for a randomized control trial, you're typically you're comparing one treatment to a placebo group, and each individual is assigned like a 50-50 chance of going to either group, and you keep doing that until the two groups are filled. But there might be another scenario where instead of comparing a drug to a placebo, you're interested in the effect of two drugs. So the factorial design especially shines when not only are you interested in the separate effect of drug A and drug B, but you're also interested in whether there's like a synergistic effect or not, basically, or maybe like they conflict with each other and maybe they're less than the sum of their parts. Basically, the factorial design is great for looking into that. So now we have four groups, and we have our bulk of people here that are being randomly assigned into the groups. So we have one group that's taking just two placebos, one group that's taking drug A and a placebo, drug B and placebo, and a fourth group that's taking both and no placebo. So basically, the randomization goes down just like it did before. And again, if you're worried about by chance some groups might be bigger or smaller, and you'd rather have every group have the same number of people, you can do blocking. And that was the second video in the series. So if we continue and we have our four groups, each of them taking two pills, but pretty much just all four combinations of the options. Now each of the four is offering something different that all are necessary in order to see if there's an interaction happening, basically. And I did a whole video on interaction or effect modification, and that one's gonna have a lot more detail and is probably a better option if interaction isn't something you understand. You should probably start there. But I'm just gonna cover it briefly, assuming you know a little bit about it. So basically, if we're looking at like these two drugs we're looking at like years of survival maybe with cancer, like in these two drugs are like chemo or cancer drugs or something. So the placebo group is baseline. Not that would be ethical to give like no drugs to someone, but just like for the sake of this example, let's say it's the length of time they'd survive if we did nothing, like if they got no drugs. And this other group is providing the information about what increase in survival do you get from drug A, basically, where let's just say it's on like a continuous scale where we're doing like months of survival. It would be like the amount of additional months of survival provided by drug A, or if drug A is harmful, like the decrease in months relative to the baseline. And this is just the increase that B provides on its own, and this is any change that happens as a result of taking both, basically. So when there's no effect modification, it's when the combined effect of drug A and drug B is equal to the sum of its parts. I guess like the biology of that is something that would probably vary from case to case, but like I'm envisioning a situation where like drug A increases survival by like a year and drug B increases survival by 2 years by some completely other mechanism that when you take both, they like stack on each other, so you'd live 3 extra years basically. That would be when there's no effect modification. And when there's synergism, it's when they're taken together, it's greater than the sum of the parts of drug A and drug B. You live longer than like you would expect if those effects of drug A and drug B were just stacked on top of each other. Antagonism is when the combined effect is less than you would expect stacked. So just in our first example, we're going to do the outcome as continuous, and then after I'll show you what it would be like if the outcome was binary. So the outcome's months of survival on a continuous scale. And the baseline survival is 10 months if you don't have drug A or drug B. When you have just drug A, it's 30 months, and when you have just drug B, it's 20 months. So if we're wondering what the expected combined effect is, this graph looks kind of weird. I don't know if you've noticed like the theme going through, but like drug A is typically like orange and drug B is typically blue. Well, this dark blue is the baseline expected months of life. And this group lived 30 months, but if we did nothing, they would have lived 10 anyway. So we're basically looking at what drug A and drug B added. Sorry, that should say drug A, and that should say... Oh, wait, actually, no. Yeah, no, I messed up. Yeah, no, that's drug A, and that's the placebo. And here within this, if your first drug's a placebo, basically the other drug can be one of two things. It can be drug B. This placebo group is the baseline group, and this is when someone got a placebo and just B, and this is when someone got drug A. Everyone here got drug A. I think what threw me off is I'm waiting to put the interaction one, or like the combined effect one. Yeah, but so this is drug A and placebo, so this is drug A alone, and this is the combined effect of drug A and drug B, basically. So yeah, basically everyone has a guaranteed 10 months because that's like the baseline, or like as long as it's increasing relative to that. This person lived 30 months, but we expected them to live 10 no matter what, so that's why the first 10 months are in blue here, and that 20 additional months that adds up to 30 is those extra 20 months are what drug B provided. And for drug A, so yeah, for drug A, it was basically like 10 of those months were given. The additional 10 was what drug A added. So on an additive scale, if the outcome's continuous, basically like we have these baseline months, and it's literally just you add the additional months from drug A and the additional months from drug B. But you don't, because it's the additional months, we already talked about that 10 months as a given, we got to subtract the baseline from each of those. So basically the additional 20 added by drug B and the additional 10 by drug A, and that comes out to an expected additive effect of 40. So you can see like we have that blue 10 months and then the 20 months added by the orange there and the blue stacked on top. So if that's what we see, that means there's no interaction, and like drug A and B aren't affecting the effectiveness of each other, but they're also not synergizing in any way. The combined effect just is like a stacked increase in months of life. If we saw synergism, so it exceeded what we expected, say when they take both the average months is 50 months, that would be evidence of synergism. And if it was 30 months, that would be antagonism. So if the outcome was likelihood of survival after 5 years, now we have this dichotomous outcome. Either you survived 5 years or you died at some point there within like follow-up in the 5 years. So this will be an odds ratio, so like odds of survival after 5 years. And basically that's on a multiplicative scale. So like before, where we were basically just combining by adding, that's because this is an additive scale when it's a linear outcome. But now we have a multiplicative scale, so the expected effect of both drug A and B together would be the odds ratio for drug A multiplied by the odds ratio of drug B. And it might help to see that in the table form like we did before. Ignore that should say a binary now. So basically the first thing is reference. So basically we're like an odds ratio means nothing unless you're comparing it to something. So basically it's like the baseline odds of like survival after 5 years, given like you haven't had drug A or drug B. And every other one of these numbers is the relative survival relative to no here, the reference. So if you had drug A, your survival after 5 years was twice as likely. If you had drug B, it's 1.5 times as likely. So what we'd expect is together, if it's like if there's no interaction, it would be 3 times more likely to live for 5 years if you take both than if you take neither, basically. If you see if you see more than 3, that's synergistic, and if you see less than 3, that's antagonistic. Yeah, so that's the factorial design.